In this second lecture for 6.1, I want to go over just 3 problems. 2 of them are from the textbook and will help you with the textbook problems. And then the last one will be question number 24 from my open math. So let's start with number 79 from page 265. We're supposed to find the exact value of this expression without using a calculator. So the first thing we want to notice is that we have a tan inverse function. That tan inverse function is going to result in an output that is an angle. So let's go ahead and use a variable of our choice. We'll let theta equal tan inverse of 12 over 5. Now, when we pick this variable, that means we also want to draw ourselves a triangle. Tan inverse is only in the first and the fourth quadrant. So since this is a positive value, we're going to be in the first quadrant. The triangles don't have to be drawn to scale, just label them correctly. So tangent is opposite over adjacent. And these numbers are really nice because we have a 5, 12, 13 triangle. Okay, so now let's go back to this problem over here. If I copy this line again, now I have a sine 2 theta. So I'm going to go to the back of the book where I see all those double angle formulas. And I see that the sine of 2 theta here is 2 sine theta cosine theta. So now I just need to replace sine theta and cosine theta using the triangle. So the sine of theta is opposite over hypotenuse, and the cosine of theta is adjacent over hypotenuse. And 12 times 5 is 60, times 2 is 120. 120 over 169 is then my final answer for number 79. Okay, so for number 87, we have the cosine function here with 2 tan inverse functions. So for each of these, I need a separate variable. I will let the first one be theta. And then I will pick another variable. So let alpha equal tan inverse of 3/4. So I have theta representing the first angle and alpha representing the second angle, and then each of these will need their own triangle. These are both first quadrant triangles. I could have left up much of the previous diagram. Okay, so opposite over adjacent. This is a 5, 12, 13 triangle again. This is theta. Here's alpha. Alpha, we have opposite over adjacent. And then that is a 3, 4, 5 triangle. Okay, so the glare has gotten in the way here. Let me see if I can readjust this. Okay, so that's what that triangle looks like right there. All right, now coming back to what we have here. This is now cosine difference, and we have theta minus alpha. So I just need to find the cosine difference formula in the back. And the cosine difference formula is cos A cos B plus sine A sine B. So in this case, we're going to have cos theta cos alpha plus sine theta sine alpha. And now we're going to replace each of these. Cosine of theta is adjacent over hypotenuse, 12 over 13. cosine of alpha is 4 over 5. Sine of theta is 5 over 13. And sine of alpha is 3 over 5. So now we have 48 over 65 and 15 over 65, which is 63 over 65. Don't forget that on Blackboard we have solutions to select textbook problems available. So there are solutions for 83 and 89 in 6.1. I'd encourage you, of course, to do those problems entirely on your own first, because you need the practice before you look at the solutions. You don't want to look at the solutions before you do a problem. That's like hearing the punchline of a joke. Before you hear the joke, it ruins the joke. And lastly, I want to look at question number 24 from the homework. We have the tangent here of 1/2 cosine inverse of 187 over 205. So let me do this one up on the board. Okay, so here is the tangent of 1/2 cosine inverse 187 over 205. First we come up with a variable. Theta is usually my first pick for a variable. You can use any one of the Greek letters. Well, you probably wouldn't want to use iota. And there are some other ones too. But, like C. Anyway, I digress. Here we have a triangle that would have to be in the first quadrant because cosine is only in the first and the second quadrant. That is, cosine inverse is only in the first and second quadrant. And here we have a positive value. Now this may be a Pythagorean triple. I don't know. Let's find out. 205 squared minus 187 squared square root 84. Oh, look at that. We do have a Pythagorean triple. How nice. Okay, so back over here. So now I need to find the tangent 1/2 formula. Tangent 1/2 formula. I have 3 of them to choose from. Considering that one of them has a square root, I think I'll avoid that one. And otherwise, it really doesn't matter, except that it's better to have a denominator that's probably more simple. So let's go with the third one. I'm going to have that the tangent of theta over 2 is equal to 1 minus cosine theta over sine theta. So now I've replaced cosine theta and sine theta. Cosine theta is 187 over 205, and the sine of theta is 84 over 205. This is a complex fraction, so I will multiply by 205 over 205, and that will give me 205 minus 187 over 84, and that's 18 over 84, and 84 is divisible by 6, so 3 over 14. A lot simpler of an answer than I was expecting. So anyway, that's how you do these problems. They look intimidating when you first see them, but they're really not that complicated once you just get your triangle up, follow the formulas from the back of the book, and they are nice, straightforward, easy problems. Put on some ambient music and enjoy.